Okay, we have section 1.3, exercise 56. And in exercise 56, we're looking at the limit as x goes to 0, I think. Yep. Of the square root of 2x, 2 plus x minus the square root of 2 over x. Now I can immediately see with direct substitution I have a problem on the bottom. I get 0. The problem on the top, if I get 0 up there, then I'm not sure what's going on because 0 over 0 is very undefined. But if I got a constant up here other than 0 when I do direct substitution, then I would just realize this limit does not exist. But here I do get 0 over 0 because if I put 0 into the top I get the square root of 2 minus the square root of 2. And so I need to do something with this, and usually when you see something like a difference of square roots, you just multiply by the conjugate, and so the limit x goes to 0. Now I'm going to take an extra step with this. It's plus x minus the square root of 2 over x times the limit as x goes to 0 of x plus, 2 plus x, doesn't really matter, x plus 2, 2 plus x, and then plus the square root of 2 over the square root of 2 plus x plus the square root of 2. So the idea is I'm multiplying by 1, right? The limit as x goes to 0 of this thing on the right is just 1 because that fraction is 1 everywhere near 0. Now, it's not 1 for x's less than -2, because if it's less than -2, this thing's undefined because I don't know how to take the square root of that negative. But as long as I'm up here around 0, this thing's fine. And so now I combine those because I have those two limits that are multiplied together. I can combine them underneath, and so I have my 2 plus x minus the square root of 2 over x, and 2 plus x plus the square root of 2 over 2 plus x, get that square root, plus square root of 2. Okay, so now I can do that. So here we've used that idea of factoring out and multiplying by 1 in the reverse order. We've built it in. And now I have on the top here this difference here, these conjugates. And so what I know, just like over here, if I took a minus b times a plus b, I know that I get a squared minus b squared. Oh, okay. So this is the limit as x goes to 0, and 2 plus x squared, square root of 2 plus x squared is just 2 plus x, and then minus square root of 2 squared, that's just 2. And on the bottom, well, we get all this nasty stuff here. 2 plus x, and then plus the square root of 2 like that. But see, on the bottom, on this right-hand part, I can do a direct substitution. I still have the problem with the x, but that's where this goes away now because I get the limit as x goes to 0. 2 minus 2 there is 0, so I just get x, and I'm going to write it this way, x over x, and then break that limit out. So I'm kind of combining a couple steps here, and 1 over the square root of 2 plus x plus the square root of 2. And so again, we get 1 here. So we use this nifty property of the multiplication twice. Once to up here to put things together, and then once to break things apart again. Once we've gotten them in some kind of form that we understand and like. Now I do my direct substitution here, and I get 1 over the square root of 2 plus the square root of 2. Well, that's 1 over 2 times the square root of 2. And again, this last part is by direct substitution. And so this is, and you know, I'm absolutely fine with writing it this way. If you want to rationalize the denominator, you can multiply top and bottom by square root of 2. Well, there we go. If I wanted to, you know, I could have square root of 2 over 4. Okay, but this is fine right there. I don't have any trouble with that. There are reasons why, you know, sort of aesthetic reasons why this last one is a bit better, and some computational reasons and number theory reasons and so forth. But this up here works just fine if you want to stop at something like that. Okie doke. Well, what was that? That was number 56, I think. So, another one done.